do your grade correction about later, okay? Let's get started. Today we are talking about algebraic expressions. So we've already practiced with this, so you guys are familiar with it, but this is the second part of algebraic expressions with just, I believe everything that we're doing today is just, no, we have two variables maybe. So we're gonna have two and then we're gonna have three. You guys okay with that? Let's get started. There we go. All right, so if it helps you, you can follow along in your textbook. We'll actually need to have that later for a few practice problems, but I am on page 12 in your textbook. All right, we're going to draw a bar model for what we do today, plus write an algebraic expression. There we go. Okay. So we're on that first page, guys. Yep, we're on the first page. All right, number one. We're going to draw the same bar model for all four of these problems. It says, if Ken has $1, how much does Jana have? And we need the textbook for this. We do need the textbook. It's not reprinted in your notes. So go ahead and open up to page 12 for sure. Not just to help you, but because you need it. How much at the picture, on the picture at the top, Ken says he has X dollars. What does Jana say? So we're all looking at page 12 in our textbook. Cameron. I have 3 times. Yeah, great job. So Ken's bar model looks like this, and Jana's bar model looks like this. So go ahead and fill that in your notes, please, where it says draw a bar model. All right, so let's just do a little mental math here really quick, and you're going to write the answers down on the numbers 1, 2, 3, and 4 below that bar model. If Ken has $1, okay, he doesn't have X dollars right now, he has $1. How much money does Jana have, you guys? Just answer. She's got $3, right? Okay, go ahead and write that on number 1. Now, that was pretty easy, right? What did you do to come up with the 3? Tommy? Yeah, you did 1 times 3, good. What if Ken has $2? Now how much does Jana have? And tell me how you came up with it. Go ahead, Macy. 6, how did you do that? Good, okay. So now what if, so write 6 on number 2. What if Ken has $3? How much money does Jana have? Just shout it out, you guys, because I think everybody knows. This is pretty easy, isn't it? You guys are doing a bunch of algebraic expressions in your head. Declan, I need you seated at your desk and taking notes, please. Thank you. All righty. Thanks, friend. If you have questions for me, let's do it. Ask during independent work time, okay? Okay, is that all right? Because we're moving pretty fast. I want you to keep up. Okay. Now, if Ken has X dollars, how much does Jana have? Shout it out, you guys.
X times $3.
Okay. Dorothy?
Just X $3.
Just X $3, okay. You guys are both right that we're gonna combine the X and the 3, right? What did we say about Macy? $3X. Remember, we always list the coefficient first. Yeah, so we just multiplied 3 times X. So go ahead and write that for number 4. $3X. You keep it up here on notes, buddy. We're gonna make sure that we write our dollar sign. Okay, and write the answer. Okay, so that looks like this, $3X. All right, parentheses. Do we have it? Ready to move on to another one? Okay, show me star, guys. We got some slouching going on. Okay, the next problem that you guys have shows the weight of a baseball and a basketball, and it's got a scale. It says express the weight of each baseball in terms of X. This is a little bit harder. How many baseballs does it take to equal the basketball? How many baseballs does it take to equal the basketball? Jace? Okay, so let's say I wanted to find the weight of one baseball. What would you do? Rajveer? Yeah, I would divide. So what would you divide? What by what?
For one baseball, for one basketball.
It would be one baseball for divided by for one basketball. Can you say it again?
Oh, divide one basketball by.
Well, if I divide it by one, I'm just going to get one. If I divide one by one, I get one, right? But it takes 4 baseballs to equal one basketball. So what would you divide? Ashlyn?
X by.
I would divide X by 4. Exactly, because we want to divide the basketball. Go ahead and write this down with me. We want to divide the basketball by 4 baseballs, right? Remember that the fraction bar means divide, you guys? Okay. So what is the weight of the basketball again? What is the weight of the basketball, Uzziah?
It's X.
It's X what?
Um,
Right there. What does that stand for?
kilograms.
Kilograms. Great job. X kilograms divided by 4. So our answer is X over 4 kilograms. Okay, now we should have copied this bar model into your notes. You guys have it? Okay, so you've got X over 4 is our expression, isn't it? You know what? I apologize. I skipped ahead, didn't I? In your notes, you had some decimals and then, so go ahead and on that slide, on that second slide on that page where it says number 2, if the weight of the basketball weighs X kilograms, what is the weight of the baseball? That's where you're going to write your expression. Do you guys see it? It's on the second slide. Nope, it's on that first page, but the bottom slide, number 2. Right. That's where you're going to write that expression. Okay, can you see it? It says if the weight of the basketball weighs X kilograms, what is the weight of each baseball? That's where we're writing the expression. X over 4 kilograms that I just wrote. Is everybody with me on that now? Yeah. Clarified? Okay, I apologize. I skipped ahead. So let me go back. So let's do a little mental math. Are you guys prepared to do a little mental math with some decimals? Are you?
Sure.
Are you sure?
No. No.
Oh, that didn't do what I wanted it to do. Okay. So backing up, if the basketball weighs 4/10 of a kilogram, okay, we're going to work in tenths for a minute with our brains. You guys prepared?
Yes.
What is the weight of one baseball? The basketball weighs 4/10. You just determined that the weight of the basketball divided by 4 is the weight of the baseball. Okay, so if the basketball is 4/10, what is the weight of one baseball? Cameron, what is it?
1/10.
It would be 1/10, exactly. So let's do 0.4 divided by 4, right? Equals 1/10. 1/10 what? Kilograms, good. Okay, continue to work in tenths. It's not really much harder than working in ones, is it? We could have said if the basketball weighs 4 kilograms, you could have told me that the baseball weighs 1 kilogram, right? Because you knew that you were doing 4 divided by 4. All right, let's go to number 2. If the basketball weighs 8/10 of a kilogram, what is the weight of a baseball? Owen? 2/10 of a kilogram. Yeah, so we're going to write that like this. Actually, let's write the whole problem. So we've got 0.8 divided by 4. Is this throwing anybody off, me using the fraction bar with a decimal and a number underneath it? Kind of, a little bit. Oh, we just need to read it from top to bottom. It's the same thing as saying 0.8 divided by 4. Go ahead, Uzziah.
Isn't like the 2 dots above the line in the fraction sign? Isn't that like the fraction
Yeah.
the X number?
Yes. That's really good insight. You mean like this?
Yeah.
Like it means
Yeah.
0.8 would go right here.
Yeah.
And divided by 4, that would go right here. It looks like the fraction bar, doesn't it? Yeah, nice. I like that. All right, what's the answer? 8 tenths. You guys should all do this. Just say it. 8 tenths divided by 4 would be what? 2 tenths of a kilogram. Good. All right. Ready to go on? Are we doing okay with this? A little? Is it confusing to work in tenths instead of whole numbers?
Yeah.
All right, how about the next one? If the basketball weighs 1 kilogram, what is the weight of the baseball? What's the answer, guys? What is it? Think of it, think of how it looks in your head. Well, tell me what it is. Actually, don't. Come on, friends. McKinley? Well, you're jumping ahead of me. Yeah, that's our expression, right? But right now in number 1 on that lower slide where you guys wrote the expression earlier for number 2, in number 1, it says if the basketball weighs 1 kilogram, what is the weight of the baseball? And remember, we're dividing the weight of the basketball by the number of baseballs. Cameron?
It's 2,500.
It would be 2,500 hundredths or 1/4 or 0.25. Exactly. So on this one, we divided 1 by 4, which would equal 0. And you know what, that could be our answer right there, 1/4. But since we've been working with decimals, we'll go ahead and write it as a decimal, 0.25 kilograms. Now let's review really quick after you stop writing. What was my expression for number 2? It said, if the weight of the basketball now weighs X kilograms, what is the weight of the baseball? What do we do just a bunch of times? Look at your diagram again. I don't see all of the textbooks open to page 12. Piper? Yep, X over 4. Good. And we can write it like this too. This is probably a more, just an easier version to look at. So X over 4 kilograms. So make sure that you have that written on number 2. Okay, how are we doing? Doing all right? We're gonna try some problems. So go ahead and turn the page to page 13. We're gonna work on practice A. And I'm gonna give you instructions. This is kind of tough. Some of these problems are a little bit wild. So we might not do all of them. We'll see. Let's look at number 1. Earl has 4 more dimes than quarters. So that's going to be true for A, B, and C, all right? Because it's at the top there. So let's go ahead and draw 2-bar model, draw a comparison model here. We've got dimes and we've got quarters. And do we all agree he has more dimes than quarters? So I'm going to draw his dimes bar bigger and the quarters bar smaller. And this difference right here is 4. All right, so for letter A, and actually, you know what? Why don't you do this with me? It doesn't tell you to write an algebraic expression, but let's do that really quick. For letter A, it says, if Earl has 10 quarters, how many dimes does he have? Well, you can tell me that without thinking too hard, right? How many dimes does Earl have, guys? Just tell me. He's got how many?
4 dimes.
No, he's only got 4 more dimes and quarters. So how many dimes would he have if he has 10 quarters? How many? Oh, I thought I heard 48. Okay, yeah, 14 sounds good. Yeah, he's got 14 dimes, right? So what we did is we took an unknown number of dimes. Well, I'm sorry, an unknown number of quarters. We could label that an X right there, and we did X plus 4, and we got 14. In letter A, the X was 10. All right, letter B, it says if Earl has 10 dimes, how many quarters does he have? Now he's got 10 dimes, okay? And we're trying to figure out quarters. So things have been reversed here. Kylie? He's got 6 quarters. We just did 10 minus 4, right? Okay, so we did this. He had 10 dimes. We wanted to know what this, whoops, what this was. Okay, so you should be writing 6 quarters there. But you should also understand why. Do you guys understand what we just did? No? Okay. Okay, no, that's all right. So we drew a comparison model. And all we know is that he's got 4 more dimes and quarters. I mean, we could potentially call this X and we could write algebraic expressions for each of these problems. I don't think I'm going to do that with you now because I think that's going to make things more confusing for you. But in letter A, we wanted to find the number of dimes he had when Earl had 10 quarters. So that meant he had 14 dimes. In letter B, we wanted to find the number of quarters he had when he had 10 dimes. So then we had to subtract. So then he had 6 quarters. Letter C, if Earl has 10 dimes and quarters all together, this one's a little bit harder now. Good. Hopefully you guys are up for a challenge. He's got 10 coins all together. How many coins of each denomination does he have? This is going to be a guess and check. So he's got 10 all together. How many more dimes than quarters does he have, you guys? To review really good. He's got 4 more, right? So we've got to let's throw out some number bonds for 10. What do we have together to get to 10? Morgan? 5. Okay, 5 plus 5, good. He could have 5 dimes and 5 quarters, right? Does that fit our bar model though? No, because that would mean that he doesn't have 5 or 4 more dimes, right? Okay, what's another number bond to equal 10? Stella?
6 and 4.
6 and 4, great. He could maybe have 6 dimes and 4 quarters, but does that fit our bar model? Because they've got to be, he's got to have 4 more dimes, right? If he has 6 dimes and 4 quarters, he's only got 2 more dimes, doesn't he? Okay, what's another number bond? Piper.
I was thinking,
Go ahead.
well, 8 and 2.
Okay, 8 and 2, that equals 10, right? So 8 and 2, he could potentially have 8 dimes and 2 quarters. But would that fit with our expression or our bar model? If he has 8 quarters, does he have 4 more quarters? I'm sorry, I'm saying the wrong thing. Does he have 4 more dimes than quarters if he had 8 dimes and 2 quarters? He would have 10 coins altogether, but that doesn't fit, does it? What's another one? Olive?
3 and 7.
3 and 7. He could have 7 dimes and 3 quarters, right? Does that equal 10? Does he now have 4 more dimes and quarters? So if we label this 7 and this 3, is everything true on that? Was that crazy hard? Not crazy hard, right? We just kind of had to think of a few things. Good. He had 7 dimes and 3 quarters. We are going to use these notes again tomorrow. So don't get rid of them. Keep them in your math binder. And let's talk about homework for tonight.
Exercise 2.
Exercise 2 is right, but I want to tell you exactly what from exercise 2. Yeah, just a second. That's you. And